The intent of this video is to help you understand how a rational function is graphed and why we get the asymptotes that we do, both the vertical and the horizontal. So the first thing we want to realize is, in order to find a vertical asymptote, as we discussed in the previous section, it's whatever makes the bottom of a fraction into zero. So for both of the equations on the screen right now, x equals 4 will be your vertical asymptote. Now, how that forms on a graph is that at 4 we can't actually find those points, but if you think about a graph of a function, when you're near 4, 2, 3, 4, as soon as we get near that point, like say something like 4.1, 4.1 minus 4 is only 0.1, so a very, very small number. But remember that if you're dividing by something small, your actual fraction gets very large. So when we get closer and closer to this vertical asymptote, your line is going to increase greater and greater and greater. Right? Or on the other side of that asymptote, you're going to get negative numbers. Something like 3.9 minus 4 would be a negative 0.1, thus causing, again, this fraction to get very large and your entire function to decrease very, very quickly and drop downwards. So that's why a vertical asymptote does what it does. Now the second type of asymptote is a horizontal asymptote. So that's we're talking y equals, or a horizontal line. Now for the first function we discussed shifting the other day. So this plus 7 is going to cause your horizontal asymptote. Because normally the horizontal asymptote would be at 0. When you put in very, very large numbers, this fraction becomes very, very, very small, thus essentially turning to 0. And when you shift that up 7 units, we get our horizontal asymptote up here at y equals 7. Now on this function, however, because there's an x on the top as well, we want to think more about a comparison. So when the x becomes very, very large, again, this bottom of this fraction is also going to become very large, but so is the top. The big thing we want to remember is when you plug in something like a million minus 6 versus a million minus 4, those extra little parts aren't going to matter all that much. It's all about whatever the term of highest degree is. And because this term of highest degree, the 3x, will always be 3 times as great as x to the first, we're going to sort of do the comparison 3x over x, or basically it becomes, 3. So your horizontal asymptote, or when you plug in very large numbers way out to the right or left on a graph, we're essentially going to become 3. Now, the 3 major parts we want to be able to find on any general rational function, a polynomial divided by another polynomial, are vertical asymptotes. So as we just discussed, how to find a vertical asymptote, whatever makes the denominator into 0. So on a function like the one we were given in the purple box here, x squared minus 4, we can set that equal to 0. And because when we solve that quadratically, we get x equals plus or minus 2. It just means we have 2 vertical asymptotes, one at positive 2 and one at negative 2. Again, another easy comparison, if a vertical asymptote makes the bottom of a fraction into 0, is how to find an x-intercept, whatever makes the top of a fraction 0. So if we take our 3x squared and set it equal to 0, and do some quick solving, divide by 3, and then take the square root, plus or minus 0, remember it's just 0, you just found your x-intercept. Now, I would probably resist actually writing the equation as I did, so I'm going to take that off there, and I would write it as a coordinate, basically saying that when y was 0, or when we set this equation equal to 0, thus making the top equal to 0, x was the input that made that happen. Last thing we're going to talk about, again, is that horizontal asymptote. It's the largest of the rules, but the easiest of the answers. Again, over here at the left, if the horizontal asymptote has equal degrees, we do a comparison like we just did on the first page. So over here, x squared over x squared, we're just going to say, well, 3x squared divided by x squared essentially becomes 3, and your answer is y equals 3 for your horizontal asymptote. Now, if the top degree would have been larger than the bottom, then the fraction just keeps growing, and we say that if n is greater than m, right here in the middle, then there won't be a horizontal asymptote. And if the bottom degree is greater than the bottom degree will always win. It's kind of like a race. The bottom degree would win, and thus you'll always be going towards 0. Your function will always be getting smaller and smaller as you move way out to the right or way out to the left on a graph. Now this next page just has a few examples for you, so feel free to pause the video at this time and try to figure out what makes the bottom or the top of your equation equal to 0, and also how to find that horizontal asymptote. Okay, and now you can see the answers for your two problems. Over here on the left, remember x-intercepts are whatever makes the top of your fraction into 0. And since -4 can't be equal to 0, there are no x-intercepts. Horizontal asymptote is just compare the degrees first. Now here, notice that there is no variable on the top, so the bottom degree is definitely greater than the top. As the bottom gets really big, the top is not changing, and your fraction will go to 0. Horizontal asymptote y equals 0. Don't forget, by the way, a good reminder for us to write y equals or x equals for all of our horizontal and vertical lines. Vertical asymptote, again, grab what takes on the bottom here with polynomial x squared plus x minus 2. Do a little bit of factoring. If we set that equal to 0 and factor, we can find that x equals -2 or +1, and therefore we have two vertical asymptotes, one at -2 and one at x equals 1. On the right side over here, again, x-intercepts, take that top part. When you solve it, you come up with two imaginary numbers, and that's another way that it won't show up on a graph, so therefore no x-intercepts. Vertical asymptote, again, whatever makes the bottom 0, since that's x squared minus 1, when we add 1, that one stays real. When you take the square root on both sides of your equation this time, you'll get real numbers, and plus or minus 1 will be your answers. So you get two vertical asymptotes again, one at +1, one at -1. Also a good reminder for us that on a graph, if there's going to be a line at -1 and +1, x equals 1 and x equals -1 here, there's not a lot of room between there, so don't be afraid to plug in some points to try to find what that graph is going to look like. I believe when you plug in 0, we get 1 divided by -1, and you get a point down here, but we don't know where the other points are. So we need to find out, are there going to be points up top or down below? Plug in something like x equals 1/2 or x equals -1/2, and that will hopefully help you find more answers and see what it comes out looking like. And then of course find more points to the right and to the left. Horizontal asymptote, again, compare those degrees since they're equal. We're going to say the leading coefficient of 1 divided by 1 and y equals 1 for our final answer. Again, here are two more examples. If you pause the video now, I will load up the answers and you can see how you did, and then hopefully your homework will go really well for you. Okay, hopefully you took a few seconds to find those parts. X-intercepts on this one, again, set the top equal to 0, do a little factoring, and you find out that x equals 2 or 3, and again, write them as coordinate points. X-intercepts are points on a graph, not lines like vertical asymptotes or horizontal asymptotes. Vertical asymptote, whatever made the bottom 0, so x plus 2 equals 0, x equals -2, and finally the horizontal asymptote, because the top degree, and compared to the bottom, top degree is larger than the bottom, squared beats first power every time, horizontal asymptote will be none. X-intercepts on the right side here, again, your work is right here for you. And you find out that x being 0 provides you with y equals 0. Vertical asymptote ends up none. Again, x squared plus 1 is not factorable. In order to solve, we have to use imaginary numbers, and therefore they won't show up on a graph. Therefore, no vertical asymptotes on that one. And finally, the horizontal asymptote, 2x squared divided by x squared. Remember, ignore the plus 1. 2x squared over x squared is just 2. So y equals 2. Remember, take any one of these equations and you can always graph them on your calculator and see what these different results will look like as far as graphs go. Hopefully that helps you out and you'll be able to do your 8.3 general graphing of rational functions homework. Have a great day.